So solving equations is kind of like the first immediate use of factoring. The next use of factoring... Where did I put my pen? Won't find my pen for me, that sucks. Alright, I'm going to have to use something else. I'll use purple. We did this the other time. We did this last time. We looked at this problem here. And we factored the top and bottom. We canceled the common stuff. I'm going to work my way back up to that. The very first thing I want to do, the minute we write these things. So these are called rational expressions. Remind me, what's a rational number? What kind of a number is a rational number? One you can reason with? No. Yeah, 1/2. Some ratio of two whole numbers. So a rational expression is a ratio of two polynomials. So these are rational expressions. Polynomial, 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 polynomial. Right? So that's why we call them rational expressions, because they're ratios of expressions. In this case, more specifically, polynomials. How are we doing so far? That makes too much sense to believe. Right? What a great thing to call it. Look at what it is. Now this level of stuff should be old news. In fact, when we learned functions, I gave you stuff like this. Didn't even talk about it really, because it's just plugging shit in. How do you do this? Number 1 here. This is page 129, by the way, in the green book. Just plug a 4, and what do you get? You get 5 on the bottom. Done. All right. So they're going to bring function notation in because they really want you to understand. It doesn't matter what the function is. It works the same. You plug the thing in. So I'm not going to do any more of those. That's all crap. Now look at this real quick. No, not that one. Here. What x can I not use?
0.
I can't use 0. I can use 1 all day. I get 5 over 6. That's fine. What happens if I try to use 0? I get 4 over 0. And that's a problem, right? What is that? Undefined. I love it. So when they ask me to find all values for which the rational expression is undefined, kick ass. That's a major clue. What's undefined mean? The bottom is 0. So what I can do is I can just say, bottom in English, bottom is 0. That's what makes it undefined. Bottom is 0. And then solve. So x equals 0 makes it undefined. Try number 3. Good Lord. Whee. That's part of it. So again, what has to happen in order for this to be undefined? What must be true? The bottom has to be 0. How do I solve this? Factor. What do I get? So what's the 2 answers? Those 2 numbers do what? Make the bottom 0. So to be honest, the way the question is asked, this is the answer, but in general, I want you to get used, if the thing is on the bottom, I want you to get used to saying why can't be those things. Why cannot be those things? Do you guys see that? Why can't equal those? Because if they did equal one of those, if y equal one of those, it makes the thing undefined. And that's freaky.
If y was 2, wouldn't it just be...
What would it be?
Oh, 4 minus 4.
There you go. Okay. I want you to really look at it. What about number 2? Why is 2 easy? Yeah, it's 3. I can see it. It's already factored, right? There's nothing to factor. It's just b minus 3. I can see it. What about this guy?
-5.
What's negative 5 squared? What's negative 5 squared? 25 plus 25 is not 0. What is this? This is a sum of squares. Can you even factor the damn thing? No. All right, you ready for this? You ready? What is the smallest the bottom can be? What's the smallest that the bottom can be?
0.1.
It can't be 0. There's using real numbers in case I have any.
Oh.
I'm not using complex numbers. So you guys are like, complex numbers. This is 25 plus something. So the bottom is smallest when that something is smallest, and that something is smallest when r is 0. So what's the smallest the bottom can be is 25.
My apologies.
That sounds like a 90s sitcom thing. Sorry. It really did. At least that small part of it, man. I'm sorry. Yes, Charles in charge. You guys see that?
Yeah.
So there's no way in hell this could be 0, because the closest it gets to 0 is 25. So what makes this undefined? Nothing. When is this defined? Always. There's no values of r, real numbers, that will make this undefined. Okay, I like it. If you do know complex numbers, just sit on that for a bit. We don't know it, so it's not going to show up yet. Okay, is that decent by itself? Do you notice something I didn't give a shit about in any of these problems? I didn't give a shit about what the top was. Can the top make something undefined? No, it can't. Top is 0, the answer is 0. If the top is something else, it's fine. It's only the bottom I care about in this kind of question. So what kind of question? When they ask you, when is it undefined? Then I worry about just the bottom. Now over here, what's the difference with these problems? Well, what's the instruction say? Page 130. Simplify each expression. You guys all right? What happened? Okay. Look at number 2. Number 1, this is old. Give me a break. Number 1, come on. How do I simplify this? 27 divided by 3 is... 9. And then how many p's are left? Okay, that's troublesome. That's old news. All right. All right. Thanks for playing. What do I do in number 2? The thing you cannot do, and please somebody tell me why. I can't reduce 20 and 12. I cannot. In fact, there is no 20 in that thing anywhere. There isn't. There's no 20. I love how some of you guys are, you just kind of go look right at it. You're like, it's right there, man. What are you talking about? But it's the same thing when I say, is there a 4 in 8? Does 8 have a 4 in it? Yeah, because it's 4 times 2. Does 8 have a 3 in it? No. Even though it's 5 plus 3, when I say in it, we know right now that I mean factor. Does something multiply to be? So there is no 20 because the top is plus 20. Please, division cannot cancel parts of addition. That's not what it does. It isn't. So don't get all, we used to just reduce. No. We never had something plus something over something plus something in the reduced. We never did. Never. So I'm not doing anything different. In fact, how would 20 over 12 work? Exactly. How does it reduce? 4. Okay. Why does that work? Because 20 is 4 times 5, and 12 is 4 times 3. So we never showed ourselves that step, but what did we do? We factored the top and bottom and killed what was common. We do the same damn thing here. How do you factor the top? Take out a 5. What are you left with? And the bottom? Take out a 3. Bam! So it is 5/3 because the r plus 4 is canceled. Now if you just did this, what the hell would you do with this? I don't know. You cannot break into an addition or subtraction problem with division. You can't. It doesn't do that. It's not that powerful. Let me see. What about... Beautiful. I love it. All right. Look at number 5. Yeah. Try to do that. Simplify that. Oh, there you are.
Just turn it off.
There you go. No, in my head, I got these images of like names at the bottom of the screen. It's like. I like it. All right, guys, I'm gonna catch up to you. The top is the easy one. Why is the top easier? There's a 1 out front, so all I got to do, I know it's M and M. Real slim shit. Yeah, so now 14 factors that make -5 would be 7. The 7's going to be negative, so it comes out negative in the middle. Is that cool? +2. Now, I'm going to do the bottom by itself, but then I'm going to try to show you a shortcut. And we'll see. I mean, if you don't like the shortcut, don't do it. But let's just pretend like there's no shortcut. How do I do the bottom? How do I factor? What do I got to do? 3 times -16 is... Thanks for the help. -48. You can do it, Jeff. So you need factors of -48 that add to be -2. I like it. -8 and 6. So then I can rewrite the bottom 3m squared minus 8m plus 6m. So I really want to make sure everybody understands that's the same thing that it was. What is -8m plus 6m? -2m. I wrote the same thing. So on one level it's like, oh, good job, Jeff. But the nice thing is now it's got 4 terms. So what can I do? Group it. So on the top I still got m minus 7, m plus 2. On the bottom now, what comes out of these two? M? No, it took an M out. 8. What comes out of these two? You want this to become 3, right? So you take out a 2. So then you finally get m minus 7, m plus 2, over 3m minus 8, m plus 2. So what cancels? Yeah, because it's this times m plus 2 divided by this times m plus 2. The division makes those cancel. You can only cancel multiplication with division. That's amazing. But really easy to forget that because our brain goes, oh, look at that. They cancel. No, they don't, brain. Stop. Only if I got multiplication. Now, I told you I was going to show you a shortcut. See when I did the top, it was m minus 7, m plus 2. I really want this shortcut to make sense, but if it doesn't, you're okay. You don't need this shortcut to do it. We did the problem, didn't we? The problem's done. You don't need this. But it's really nice if you see this. The only way this could possibly simplify is if the bottom has this in it or this in it. Does that make sense? You got to have one of those two things so you can cancel. Otherwise, what's the point? Right? If I said simplify 9 over 11, you're like, I'm done. What's the point of that shit? There was nothing in, nobody had anything common to both. You guys see what I'm saying? Maybe. Again, you don't need this, so let me just keep going. Could this possibly be this? Could 7 make 14? Yes, it could be. Oh, that kind of sucks. I'm sorry, looking at 16. Does 7 make 16? Because 7 times something is 16. No, so it's got to be this dude. Now watch, this is so cool. So the bottom has to have an m plus 2. What goes here to make this work? Well, 3m squared is m times 3m. And to make negative 16, it's got to be 2 times negative 8. And just check, make sure you get the middle term. Negative 8m plus 6m is negative 2m, therefore that worked. Now again, you don't need that shortcut. If it doesn't make any sense, don't use it. That's fine. If it makes some sense, oh, it's so beautiful. You're going to save a little bit of time. Right? So if you didn't get that at all, you're fine. If you got this, you're okay. If you didn't get either one of those things, that sucks. So like on number 7, oh yes sir.
So the answer for that would be
yeah, let me make it really so m minus 7. over 3m minus 8. Bam. All right, so even if I do many, many examples and I keep saying it, I'm still going to have somebody just cross through these two things. Part of me can't blame you. Your brain just goes, that's awesome. But of course, we can't do that shit, right? We can't do that on this. So some of you guys might realize that shortcut, if I factor the top or the bottom, I could use the idea of the shortcut to make this quicker. I don't need it, though. It's just a shortcut. So this is really good practice for doing these. Go ahead and try to do number 7. If you think you understood the shortcut, see if you could do it that way. I think you guys are starting to see what I meant by if you cannot factor, you cannot do chapter 7. Period. So if you have a lot of trouble with factoring, you just want to focus on that right now. You gotta like this one. The answer is just staring you in the face. So one thing you can do for yourself is to break this up into 2 parts. Factor each of these pieces and then put them back in. Become a 13. Man, that 13 was mutilated. Oh well. So here I need factors of negative 10 to add to be 3, but that of course is going to be 5 and negative 2 right there. Yay! So I do 5y squared. I could do plus 5y, why not? Minus 2y minus 2. Is that decent? That's a good old surefire method, right? Chabow. So then take it out 5y and then negative 2. So the top looks like this. That's the top. The bottom I've got to still do, so here I've got to get negative 30. Factors of negative 30 that add to be 13. Yeah, this one's a little evil. It's not 10 and 3 because they have to be different signs. So they can only make a 7 or a negative 7. So it's got to be 15 and 2. Which one's negative? The smaller one, so that it comes out positive. So now I rewrite this. 5y squared. Let's put the negative one first. Right now. 2y plus 15y minus 6. And then I group. So you get a y comes out. 3 comes out. Become a parenthesis. Parenthesis. You guys see why I don't want you guys using pen. It drives me crazy. So then you get 5y minus 2y plus 3. You can already see what's going to happen. This is the bottom, so put it back together. So I tore apart the top and bottom so I could work on both of those problems. Now I put it back together. On the top is this dude. On the bottom is this dude. What cancels? So then the answer is y plus 1 over y plus 3. Well, y? Jeez. I'm in major trouble. So if you understand factoring, chapter 7 will be easy. The less you understand factoring, the harder chapter 7 will be because it's all factoring. Oh, shit.
Can you use the shortcut on that one?
Yes, totally. If you did the top, you know that 5y minus 2 is probably going to be a part of the bottom. So then you can build. So if I say, there's no door there. I'm not sure. Come in. Oh, yeah. It's like you never used to knock before. Some of you guys got it. So if I assume that that's a part of the bottom, 5y times what is 5y squared? Y. Negative 2 times what is negative 6? 3. And isn't that what we got for the bottom? So some of you guys, I'm sure, are looking at it like, that's magic. Stop it. If you don't understand this, that's okay. In fact, most of my colleagues don't even show this to people, but I like to show it just in case you get it. The more you understand, the less you should have to do. Yes?
So you assume 5y minus.
Yes. And if it's not, if it doesn't work, then I just try to factor that, or maybe it's not going to work. But the whole thing is built on the fact that there's got to be a piece that's the same between both of them. So assume that one or the other piece is the same. Okay. Ooh, I love it. Now help me out. Somebody remind me. How do I do a problem like this? Somebody remind me. This is from old times. What you got, Jeff? 14 over 15 times 25 over 28. Oh, okay, so you factor.
Oh, you didn't reduce it.
So 14 is 7 times 2. 15 is 5 times 3. 25 is 5 times 5. 28 is 7 times 4. Ooh, it's even better than I thought. I could have done a whole 14. So here I get 5 goes away. 7 goes away. 2 goes on, blah, blah. But yeah, of course, you do like this, right? 5 goes into both 5 and 3. But it's because you don't have to show yourself this because they're just small numbers. And you can kind of do that in your head. I don't have to show myself them factoring, right? I could just go ahead and start killing stuff. But when I have a problem like this, see this one. These are kind of dumb. What would I do here? Real quick. This one's already factored for us. So 5, what can I do with 5? Yeah, 5 goes into 30. 6 times 6 and 2 goes down to 3. And what about a plus b's? What happens there? Cross through what? How many? 1 a plus b, so I get 1. So what's left over at the end? Anything left on the bottom? Nobody's left alive on the bottom. What do I got on the top? 3 times a plus b.
How'd you cross out 2?
Yeah, why did you do that?
2 goes into 6 3 times. 5 goes into 36. 2 goes into 6 3.
I don't like that.
Aw.
So why'd you cross out the
Cross.
on the top?
Okay, so we do this again.
So we just pretty much left 1.
You ready? Yes, exactly, because one of them died. All right. Here we go, guys. So 5 goes into 30 6 times. 6 divided by 2 is 3. How many a plus b's cancel? 1. So there's nothing left at the bottom, but there's 1 of these left on the top. Do you guys see that? If that would have been a 3, I would have crossed it and put a 2 there. Because I'm crossing through one of... Or you can write it twice. So that when you cross through an a plus b, you can see there's 1 left. But don't do that, because what if the power was 28? I don't want to write them 28 times. Yes?
So you're able to cross the bottom a plus b out because it was on the bottom, the other one on the top, right?
Yes, you can always cross through stuff if there's one of them on the top and one of them on the bottom.
What if it had been a minus b?
What, is it the same as a plus b? No, they're not the same. So you can't cross through them.
Oh.
The only reason these cancel, one of these cancel, is because it's exactly the same. I like it. What's 7 plus 3? 10. Well, let's do it this way. What's 7 plus 2? 9. What's 7 minus 2? 5. So totally different. A plus B is totally different from A minus B. So they wouldn't cancel each other. They're the same thing. So what would I do on number 3?
Take out the greatest common factor.
Yeah, what do you do? Do you notice that is that's section 7.1. I don't know if you guys notice, I've snuck into section 7.2. Just gives me one more stupid thing. What do? I factor, then kill. Whatever's the same on the top and the bottom. This is really good to be teaching this around Halloween. Michael Myers. Michael. So yeah, you factor. How do you factor this guy? 8, and what's left?
4 plus 2.
How do you factor the bottom? 24, and what's left? R minus 1. And you factor the top of this guy. 6. R minus 1. 3. So look at the R stuff. What cancels? R plus 2's cancel, R minus 1's cancel. Yeah, 8, 24 goes in 3. What about 6 and 3? 2. So what's the answer? What's left alive? Here's the hard part. You got to be really nice to yourself and really keep track of what's alive. You don't want to leave anybody behind. Who's alive on the top? 2. And who's alive on the bottom? 3. Done. So no matter what R is, the answer to this is 2 over 3. That's kind of nifty. All the R shit cancels. Okay? So what are they going to do to us? Look at number 5. And then we'll do number 4, believe it or not. Let's look at number 5 first. Go ahead and try to do number 5. So now you start to break up 13. But it should be, so trying to get things to multiply be 30. And 2. 3 is 45. But it's got to be positive. There you go. Now you can break up the middle either way you want to, but you can break 5y squared plus 15y minus 2y minus 6. And then you got a group as well. Give you guys a little more light. Oh, that's good. So now you just start looking at anything. So you could have went this way, but somebody just said to do this. I'm like, okay, cool. Reduce, reduce, reduce. Yep, all your R shit's done. Now it's just the numbers. Reduce your numbers.
Yeah. So you just, I just have a question about the 21. Stay on the outside.
Oh yeah, because we got it's just 4. All right, let me catch up to you guys. So you see how this is like 4 problems? One of the problems is easy. That's z minus 5, I can't do anything. It's basically 4 problems in one. But you know, math people are like, oh yeah. Let's really screw their students over. But this is what I mean by the better you understand factoring, the easy the stuff is. So how do I factor this piece? So z minus 5 I can't do anything with.
Z minus 3, Z plus 3.
Z minus 3. I'm having a lot of trouble today writing. Here, like today. What about this guy here? How do I factor this guy? So I got a 2. Z minus 5, I like it. What about the bottom? Oh boy. Yeah, little dude, big dude. Z plus 3.
Z squared
Minus
minus 3.
3.
Plus 9.
No, Z. It's got to be these 2 multiplied. Plus the other 2 3's 9. I like it. So now what cancels? Z minus 5 cancels, because it's on top and down below. Z plus 3 cancels. And that's it. So what's left alive on the top? 2. Z minus 3. What's left alive on the bottom? The big dude. Done. Just to remind you guys, if you made z some specific number, and you figured out what these fractions were, they would multiply to be whatever this represents. Believe it or not. We've done that before. Now, last thing for today. What's the difference between multiplying fractions and dividing fractions? Is there really a big difference? Like, how would you divide these? Yeah, multiply by the reciprocal of the second dude. So division is multiplication. You just got to flip the second dude, right? So if I saw a problem like this, well, let's do this one. Ah, screw it. Give me a normal problem. Yeah, there we go. What's the first thing you would do? Flip the second dude and factor it. I love it. You can do those kind of at the same time, right? So division of these things is the same as multiplication. You just got to flip the second dude. It's nothing new. It's just that first step. So how do I factor the top here? What do I do with this? How do I factor this guy?
Plus 3 negative 2.
Good. Bigger one's positive. I like it. What about the bottom there? Numbers that multiply by negative 12 added before. 6 and 2. The bigger one's got to be positive. The bigger one is 6. Sorry. I appreciated that. And then what do I do with this? Flip it. That's all I got to remember is to flip the division. You got to flip that second dude. And then what do? Same thing we were doing before. Kid, die, die. What else? Anything else die? Yeah, you die, die. So what's the answer? Kabam. So division is multiplication after I flip that second dude. Nothing new to learn. Just remember to flip it. And flip it good. Sorry. A little Devo math. What about this guy? What would happen here? Good, because right now, good Lord, Jeff, stop yelling at people. Right now it's over 1, so when I flip it, it would become 1 over x minus 3. You factor all this stuff. Kill whatever's common. So 7172 basically have the same ideas. You factor, 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 and then kill, kill, kill. So the next thing we'll do is learn how to add, subtract. What do you need in order to add, subtract things that look like this? Common denominator. And you're going to have expression. Oh, so yummy. So we'll get into that next time. By the end of this week, we'll know what's going to be on the next test.